All right, these are your notes for identifying linear functions, 5.1. Your essential question, which you do have to write down. You can pause and rewind as many times as you need. Your essential question is, describe the relationships between the equation, a table, and the graph for y equals 2x minus 1. Describe the relationships between the equation, the table, and the graph for y equals 2x minus 1. So remember, you want to solve that and then put your solution in your summary of your Cornell notes. Alrighty, so let's talk about identifying linear functions. The first way you can identify a linear function is just by looking at the graph. Remember, linear function. First basic rule is it's got to be a function and it's got to be a line. Hence the word linear function. So, our first graph example looks like this. This is a linear function. Okay? Each domain, or x value, equals one range value. Each domain equals one range value. So this is a function. So it is a function. Okay? Remember, you can also use your vertical line test. If you can draw a vertical line through the graph anywhere, and it only touches your graph in one spot, then it is a function. Then you look at it. Is it a line? Yes, it is a line. Okay? So it fits that it's a line. It fits that it's a function. So yes, this is a linear function. Okay? All right, that's the first one. The next type of graph that you might have is, looks like, draw my coordinate plane. This is called a parabola. Okay? This, first of all, is not a line, it's a curve. Okay? So you have a parabola, so this is not a line. Alright, so first of all, that's going to tell you it's not a linear function, but this is a function because I can draw my vertical line. Okay? It is a function, but it is not a linear function. Right. Next one. Draw my coordinate plane. If this were my graph, this is not a function at all, linear or otherwise, because a vertical line is not a function, because if I drew the vertical line test, it's going to hit the graph the whole way down, all the way down, every single point. So this is not a function nor a linear function. All right. Next example is identifying a linear function using ordered pairs. So maybe it gives you a list that says 2, 4, 5, 3, 8, 2, and 11, 1. Okay? And you need to determine, is it a linear function? Okay? The easiest way to do this is to set up a table. So I'm going to put x's and y's. My x is 2, my y is 4. 5, 3, 8, 2, 11, 1. Okay? And once you have your ordered pairs, you can see if it does a function. First of all, you can see that yes, this is a function so far, because each one of my range values, or my domain values, has one range value. Okay? It's not 2 is 4 and 2 is also negative 4. So that tells you it is a function, but is it a linear function? Well, the first option is you can draw a graph, and you can go to 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is my lazy graph. Alright, so we go to 2, 4, 1, 2, 1, 2, 3, 4, 5, 3, 1, 2, 3, 4, 5, 1, 2, 3, 8, 1, 5, 6, 7, 8, So these points will satisfy a linear function. There's no curve. If I do my vertical line test, it's only going to hit it in one place. So these points do satisfy a linear function. Okay? If it had given you more points, and maybe our line did something like where it started curving down, then it would not be a linear function anymore. Okay? The other way to try it, if you don't want to draw a graph, is to look at your points. Okay? If you jump from here to here, and from here to here, that's plus 3, and this one's plus 3, and this one's plus 3. Okay? They're all the same. Okay? It's a constant change. It's not jumping all over the place. And do we have a constant change over here? Minus 1, minus 1, minus 1. There's a constant change. So if a constant change, then it is a linear function. Okay. So if you have a constant change, it is a linear function. Let's look at some different numbers, and you can see where it's not a linear function. Looking at the change is a lot faster than graphing. If you ask me, it takes a whole lot longer to graph. So what if I had negative 10, 10, and then negative 5, 4, and then 0, 2, and then 5, 0. Okay? From there, I can look at it and see, well, this is plus 5, this is plus 5, and this is plus 5. So that's a constant change. Great. But now we have to look at the y side. It's got to be a constant change too. This is minus 6, minus 2, minus 2, minus 2. Okay, so this is not a constant change. So that means this is not a linear function. Alright, not a linear function. Alright, the next part that you need to know, you want to put a big box around it, you want to highlight it, put it in pretty colors. This is really, really, really important. You'll need to know it through every math class you take from here on out. Okay? It's called the standard form of a line. You're going to get on your EOC, it's going to ask you to put a problem in the standard form of a line. Okay? Standard form of a line looks like this. It's AX plus BY equals C. That is your standard form of a line. And whenever you have it in standard form, x and y both have exponents of 1, so there's no exponents, there's no squared, there's no cubes or anything like that. X and y are not multiplied together, okay? And x and y do not appear as denominators in a fraction, they're not exponents, and nor do they have any radical signs on them, okay? Your last example is graphing linear functions. To graph a linear function, it's a 3-step process. To graph a linear function, here are your steps. Okay. Step 1, make a table of x values. And that table of x values can be anything you want, but you want to have 0, you want to have a negative number, and you want to have a positive number. And I say you need to have at least 3 numbers, but 5 is better. If you don't have at least 3, you can't connect the dots to make a line. So make a positive number, a negative number, and 0. But they can be anything you want unless numbers are given to you in the problem. Step 2, solve the function for each x value. Okay? And then step 3, graph the ordered pairs from your results. Okay? So we're going to do an example. If my equation is y equals x plus 3, step 1, I'm going to make a table, x and y. I'm going to use -3, 0, and +3. Always put your negatives at the top and your positives at the bottom. So now I'm going to solve. And actually here in the middle I'm going to put my math. And then I'll put my y's over here. Okay? So I have -3 plus 3, 0 plus 3, 3 plus 3. Now you solve. -3 plus 3 is 0. 0 plus 3 is 3. 3 plus 3 is 6. Okay? Once you have those, you can put your ordered pairs together by just putting x comma y. My x was -3. My y is 0. My x was 0. My y is 3. My x was 3. My y is 6. And those are your points. And then you can graph. You can graph on notebook paper or you can graph on graph paper, whatever works for you. But it doesn't have to be perfect. You don't need to get out a ruler. Okay, you can also go online and find on the handouts of the website or just Google cute little coordinate grids already made for you, like 6 to a page. You can use those too. So this is -3, 0, so 1, 2, 3. And then we have 0, 3, 1, 2, 3. And then 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. Then you connect your dots. Always put arrows on the end of your line because they extend, because we didn't solve our problem for every answer. Remember, x goes across, y goes up and down. You've got to go across before you can go up and down. All right? And that's how you graph. Good luck.